This is SpaceTime, Series 26, Episode 79, for broadcast on the 3rd of July, 2023. Coming up on SpaceTime, new questions about whether Jupiter's ice moon Europa could actually host life. A new survey studies the blue supergiants. And weak magnetic fields detected on Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has raised some concerning questions about whether the subsurface oceans on the Jovian ice moon Europa could actually host life. For years, scientists have speculated that Europa's oceans could contain chemical nutrients capable of potentially providing a habitable environment for some sort of life beyond Earth. After all, entire ecosystems based around chemosynthesis populate the deep-sea mid-ocean ridges of Earth, and scientists speculate that these isolated colonies may be where life on Earth began. Europa, which is only slightly smaller than Earth's moon, contains more liquid water than all the Earth's oceans combined. The water is contained in the massive subsurface global ocean, protected from space by a thick icy crust. Observations of Europa have revealed occasional plumes of water ejecting out into space through fissures in the ice. Scientists have long speculated that Europa is made up of 4 distinct layers. There's the icy shell, which we see. Below that is the deep saltwater ocean, which we know is there. Then there would be a rocky mantle, and finally at the center, a metallic core. They think that, like the Earth, Europa's oceans touches a rocky seafloor, which may allow rock-water chemistry to interact, which would be favorable for life to exist. And like Earth's mid-ocean ridges, it's possible the European seafloor, and yes, that's how you say it, may host volcanoes, which could then provide more energy and nutrients for a potential biosphere. However, a team of researchers from Arizona State University, undertaking computer simulations of how Europa may have formed, have come up with some shocking results. Kevin Trini, Carver Bearson and Joe O'Rourke were investigating the consequences of Europa actually forming with low initial internal temperatures. Most studies of Europa suggest that its water is derived from hydrated rocks, that is, rocks containing hydrogen and oxygen, creating an ocean of metamorphic origin. Trini and colleagues show that if Europa indeed was formed from hydrated rocks, then enough of Europa's interior should get hot enough to release water directly from these hydrated rocks to form the ocean and icy shell. Trini says the origins of Europa's moon is important because the moon's potential to support life ultimately depends on the chemical ingredients and physical conditions during the ocean's formation process. Many scientists studying the icy moon simply assume that Europa, like most planetary bodies, formed with a metallic core either during or shortly after its accretion. But the Arizona State authors, reporting in the journal Science Advances, contradicts that prediction, instead arguing that Europa may not have started forming its metallic core until billions of years after accretion, assuming it happened at all. You see, for most worlds, we think that their internal structure was pretty well set shortly after they finished forming. But this study is reframing Europa, showing it to be a world whose interior has been slowly evolving over its entire existence. And that opens the door for future research to understand how these changes might be observed in the Europa we see today. See, the existence of a metallic core is deeply tied to Europa's internal heat, which may also be used to drive seafloor volcanism and contribute to a habitable seafloor environment. Problem is, it's unclear right now as to whether Europa generates enough heat to form such a core. The author's work calculates how heat is generated and distributed throughout the moon. And they do this using the same governing equations that many geodynamicists have been using for decades. The team's novel result, however, comes from challenging the assumptions common to Europa's modelling. A small moon like Europa could form as a cold mixture of ice, rock and metal. Remember, Europa's really only got about 1% of Earth's mass, so you can't really think of it the same way you think of the Earth. It means Europa may not generate enough energy to trigger or sustain Earth-like processes such as metallic core formation, seafloor volcanism, or ongoing rock-water geochemistry. And all that implies Europa's true habitable potential is uncertain. The exact time at which Europa formed determines how much heat's available from the radioactive decay of short-lived isotopes such as aluminum. Short tidal heating from gravitational interactions with Jupiter and the other Jovian moons also governs how quickly Europa's interior separates into distinct layers. The simple fact is, Europa's seafloor may be cool, hydrated, and experience limited, if any, seafloor volcanism. And that implies there may be very little, if any, hydrothermal activity, which would hinder habitability. Now, NASA's Hubble Space Telescope has taken direct ultraviolet images of Europa as it transits across the disk of Jupiter. And on some of these transits, it spotted water vapor plumes erupting from beneath the European surface. Now, similar geysers have been detected spewing out of the South Pole Tiger stripes on the Saturnian ice moon Enceladus, which also contains a global subsurface ocean. And the composition of these plumes were carefully studied by NASA's Cassini spacecraft as it was exploring the Saturnian system. Cassini found the Enceladian plumes contained a variety of minerals and chemicals suitable for a habitable ocean. NASA plans on launching the Europa Clipper mission in October 2024. It'll arrive in the Jovian system in April 2030. Once there, it too will search for plumes of water erupting from beneath the European surface. Only then can we be sure as to whether or not Europa's oceans are indeed habitable. This report from NASA TV.
NASA's Hubble Space Telescope has directly imaged what may be plumes of water vapor on Jupiter's icy moon Europa. Europa has long been thought to harbor a global ocean of water beneath its surface of ice, making it a prime target of study for anyone interested in searching for alien life. Eventually, our search for life will take us into that ocean, but until then, the existence of a water vapor plume would provide an early glimpse into the ocean's conditions. In 2012, a team of astronomers used the Hubble Space Telescope to observe a faint aurora from the interaction of Europa and Jupiter's magnetic field. They detected emissions in wavelengths characteristic of the breakup of water molecules, and after considering a wide variety of causes, the team concluded that the most plausible explanation for these spectroscopic measurements was the existence of plumes of water vapor erupting from the surface of Europa. Now, a different team of astronomers has used a different method with similar results. They used Hubble to image Europa in ultraviolet light as the moon transited across the disk of Jupiter, and were actually able to take direct images of what appear to be the silhouettes of plumes rising about 125 miles above the surface of Europa. If these observations are indeed of water vapor plumes, then they approximately match the 2012 observation estimates for the plume's mass, height, and location. Also, these plumes are transient, meaning they come and they go. Out of 10 observations of Europa transiting across Jupiter, the team saw possible plumes on just 3 of the transits. Both the recent observations and the 2012 observations provide evidence, not proof, of water vapor plumes on Europa. Science is a process, it's not always cut and dried. But future observations by Hubble and infrared observations by the James Webb Space Telescope could continue to build a case for the existence of these plumes on Europa. And then NASA's future Europa flyby mission would continue the search for the plumes and visit them to look for evidence of a habitable underwater world.
This is SpaceTime. Still to come, a new study looks at the biggest stars of all, the blue supergiants, and China's Zhurong Mars rover discovers weak magnetic fields on the Martian surface. All that and more still to come on SpaceTime. Astronomers have undertaken a major survey looking at some of the universe's most massive stars, the so-called blue supergiants. The hope is to eventually unlock some of their secrets. The observations, reported in the journal Astronomy and Astrophysics, examined some 750 of these massive stars within an area 6,500 light-years from Earth. making this one of the most complete and highest quality samples ever undertaken. Understanding these giants is important because stars are the basic elements of construction of galaxies, and therefore of the observable universe. But among the many different types of stars, there are some whose masses are more than 8 times that of the Sun. These massive stars, with their intense radiation and powerful stellar winds, impart a significant impact on the surrounding interstellar medium. And the interiors of these massive stars are major chemical factories, changing the entire composition of the universe. These stars, during their lifetimes and when they die, produce all the elements on the periodic table, other than the hydrogen and helium which was produced in the Big Bang 13.82 billion years ago. And that makes them crucial, not just for the chemical evolution of the universe, but also for the appearance of life itself. Being so massive, these blue supergiants burn through their nuclear fuel supplies really quickly, usually living for just a few million years, compared to the 12 billion year lifespan for smaller stars like our Sun. Previous studies of these giants hasn't been able to obtain enough information to really understand these stars in detail. That's where this survey's come in. It spent the past 15 years obtaining spectra of these behemoths, thereby providing high-resolution details of their composition. The study's lead author, Abel de Burgos Sierra, from the Canary Islands Institute of Astrophysics, says these stellar fingerprints will allow astronomers to tackle some of the big questions about the evolutionary nature and physical properties of these giants. Questions which have gone for decades without solution because they were less well known than other types of stars with less mass. To find these massive but still fairly rare stars in the universe, a new method of flagging was used, based on an easily identifiable tracer in the spectra of these stars, the shape of the profile of their hydrogen beta line. This allowed for the rapid identification of the stars with a specific range of temperatures and surface gravities, rather than going through the usual method of complex spectral analysis based on stellar atmospheres. Astronomers are now planning a new 5-year program in order to observe and catalogue many more of these stars, with the ultimate aim of producing the largest ever database of the spectra of these massive stars within the Milky Way galaxy. This is SpaceTime. Still to come, new data from the surface of Mars shows that its magnetic field's much weaker than expected, and later in the science report, a new survey links increased use of vitamin D supplements to reducing the risk of heart problems. All that and more still to come on SpaceTime. New data released from China's Mars-Zhurong rover shows that the local magnetic field where the rover was operating is far weaker than anyone expected. The data, reported in the journal Nature Astronomy, indicates the magnetic field strength in the Utopia Basin region where the rover was running was an order of magnitude weaker than at the location where NASA's Mars InSight lander touched down, some 2,000 kilometres away to the southeast. The findings are based on recordings taken during the rover's first kilometre of travel across the red planet's surface. And the extremely weak intensity of the magnetic field suggests no detectable magnetization anomalies below Zhurong's landing site. Zhurong is the first rover equipped with magnetometers. The researchers utilized 2 fluxgate magnetometers aboard the rover to conduct the first magnetic field survey of the Utopia Basin. The results from the Mars InSight lander were an order of magnitude stronger than that inferred from orbital measurements. But the measurements from Zhurong revealed the opposite result, with the average intensity an order less than what was inferred from orbit. The extremely weak magnetic field detected by the Zhurong rover implies that either the crust beneath the Utopia Basin may have remained unmagnetized since its formation 4 billion years ago, or it was demagnetized by a later sizable impact, probably during the early Hesperian epoch. This new constraint on the timeline of the Martian dynamo sheds further light on the interconnected magnetic, climatic, and interior history of the early red planet. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that vitamin D supplements could play a modest role in reducing the risk of heart attacks, strokes, and other heart problems. Previous studies had linked low vitamin D levels with increased heart risks. The new findings, reported in the British Medical Journal, follow a randomised test of over 20,000 people between the ages of 60 and 84 who received either vitamin D supplements or a placebo to see if this impacted the risk of heart problems. And after following up for an average of 5 years, scientists say 6.6% of the placebo group ended up experiencing a major heart event such as a stroke or heart attack compared to 6% of the vitamin D supplement group. The authors say that while the difference in risk is small, it does support the need for more research to find out exactly what the role vitamin D plays in the cardiovascular system is likely to be, and how this could help people who already have heart issues. A record 315,705 babies were born in Australia in 2021. That's the highest annual figure on record. The data is contained in a report from the Australian Institute of Health and Welfare. It shows the birth rate in 2021 was 61 births for every 1,000 women of productive age. That's up from 56 births per 1,000 in 2020. The findings also show that women are continuing to give birth later in life, with 1 in 4 women giving birth aged 35 or older during the year. Now, despite the health risks of having a baby later in life, the report shows more than 9 in 10 babies born to women aged 35 and over were born at term and at a healthy weight. Okay, if you're like me and you feel a coffee in the morning is needed in order to get energized for the day, well, Spanish and Portuguese researchers say that boost you're getting could all be in your head because they can't replicate it with plain caffeine. The scientists scanned the brains of regular coffee drinkers and then gave them either a cup of coffee or the equivalent amount of caffeine, and then scanned their brains a second time. The findings, reported in the journal Frontiers of Behavioral Neuroscience, showed that while both coffee and regular caffeine activated areas of the brain that make you more alert, areas of the brain associated with working memory and goal-directed behaviour were only activated by those who had the cup of coffee. And while we're on the subject of things that may be affecting us not quite the way we think they do, a new study has questioned the link between sugar consumption and kids going wild. Tim Mendham from Australian Skeptics says, while we've all seen kids getting hyperactive after consuming candy and cake at a party, it turns out the connection isn't really there.
Sugar and hyperactivity, there's nothing better than going to a kid's birthday party and finding 20 little children rushing around like crazy, bumping into each other, playing the musical instruments they've just been given, all the horns and the drums, guaranteed to help your sanity. The suggestion is that sugar plays a big part in that. In hyperactivity, you give a kid a colourful cordial drink or a lot of Christmas, a birthday cake, etc., that they will then go around and go berserk. Everyone sees it, that you give a kid a birthday cake.
Yeah. So
they see an association which is not necessarily there. Yeah, they see an association which is not necessarily there. Kids running around at a birthday party is not unusual, whether they've had cake or not. So the interesting thing is someone's done a bit of research on this, someone has kids, and looked at it and said there's probably no way that a single serve of some sugary concoction will make kids go hyperactive. Give them a diet based on sugar everywhere. And, of course, sugar is in basically everything we eat. But, give them a high sugar content in their complete diet. Yes, then you might have particular health issues. But this one-off thing of don't give a kid a glass of cordial because they'll go berserk is not well founded. In fact, this person points out that this particular myth had its origin in one published scientific article, which they might consider it unethical today, this thing, from the 1970s. And this study examined the effects of foods on the autistic behaviour of one child. So you got a study of one, and there was one paper that blew up this thing out of all proportion, right? That sugar was considered one of the foods that caused disruptive behaviour, and it's really unfounded. Now, people think, it's become a commonplace belief that sugar causes this. Not true. As far as the scientific evidence goes, and the later analysis and stuff has not necessarily done any greater service in supporting the theory. But sugar comes in all forms and shapes and sizes, and there's various sugars in everything, and there's 4 key sugars that...
different molecules,
Different molecules, and they combine, and they form others that are forms of sugar, etc. etc. You're looking at quite glucose, fructose, galactose, and ribose, right, which is 4 out of more than 20 sugars that you might find in the foods you're eating. And these 4 combine and do different things. Sometimes they do it by themselves and sometimes together. And so that is the issue with these sugars. It's probably long-term overdose of sugar that causes these sort of problems. And it's not just hyperactivity. It could be diabetes or all sorts of things. But a single cake at a birthday party is not going to do a lot of damage.
Probably the 3 or 4 bits of candy they had before they went to the party, that's the problem.
Study suggests that really what parents are seeing is a cause and effect that doesn't exist. They find a correlation, and as we say, correlation does not mean causation. So just because you see 2 things happening at the one time doesn't mean A causes B.
It's amazing how that's spread.
It's spread everywhere.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.